So for my last video, I wanted to do something bigger than anything I've done this year, so what I ended up deciding on was a mission to Jool, in which I would assemble a big ship in orbit using multiple launches. So because it was such a big mission, I split up the recording of it into a few days, and during that time, Kerbal Space Program got a big update which broke most of my mods and basically destroyed all of the progress I had on the orbital assembly. So that brings me to the video you see now. I've just finished recording and trimming down about 4 hours of footage, and for this one, as you've seen from the title, I went with the slightly less ambitious destination of Duna with the intention of building a space station in orbit there. My plan is to split the mission into 4 different segments. The first module, which will be the core containing monopropellant, SAS wheels, liquid fuel, and oxidizer. The second module, which will produce and store power for the whole station with solar panels and batteries. The third module, which will contain Kerbals to live on the station with a living area and viewing deck, and the fourth module, which is a spaceplane that can dock and refuel at the space station before heading down to the surface of Duna and back up again. What you see on screen now, of course, is the core module, and this was probably the easiest module to build and fly in my opinion, since I don't need to rendezvous with anything, and it's basically just a perfectly symmetrical tank of gas. Unfortunately, said gas is extremely heavy, so this will need the largest transfer stage of the 4 modules to go up. The ascent stage that I used for all the rockets in this video are basically the same, with slightly different amounts of fuel distributed between the ascent stage, which always uses the Rhino engine, and the transfer stage, which always uses the Mammoth engine and some combination of Clydesdale solid rocket boosters. As always, the boosters will have attached 16 Cybertrons per booster to launch away the spent boosters on ascent and will be held in place by decouplers and struts. On the bottom, launch clamps are attached, and we can go ahead and get ready for launch, after I add one little tank of fuel at the top just for good measure. And so we have the first of our 4 launches out of the way. We'll go ahead with our standard flight plan of pointing 45 degrees at 10 kilometers to ensure the most fuel efficient ascent possible. You might also notice that the engine plumes look a bit different. One of the mods that broke was Real Plume, which hasn't updated yet, so I switched to a similar mod called Waterfall, which has pretty similar looking textures and is much easier to install. I should mention a pretty consistent issue I had with basically all of these modules except the power module was that I kept running out of electric charge, and without electric charge, you can't extend solar panels, throttle rockets, or operate the ship in any way since it's controlled by a probe, which requires electricity. So if you notice any weird cuts, which hopefully you don't because I was pretty careful to cut the video in and out at hard to notice places, that was just me cutting out parts where I had to load quick saves. Another consistent mistake was that I kept forgetting to launch at Duna transfer windows, which, to find a Duna transfer window, you draw a line from Kerbin to the sun to Duna, and the angle that the line forms at the sun should be about 45 degrees. Anyways, it's not really a big deal because we can just leave the ship orbiting Kerbin for a few months, but it's generally just standard practice to hold off on launching until you're already at a transfer window. I'm sure you've noticed that this video is way longer than my usual videos, and I assure you that this really is the shortest I could have made the video and still show everything. Like, I must have cut out an entire hour of me making mistakes and not realizing until like 15 minutes after the fact and going back to a quick save, so I'm sorry it's so long, but I've sped up almost everything by 500% and cut out every unnecessary bit I could find. That said, we're now well on our way to Duna, and Duna is a comparatively easy destination from Kerbin because it has almost no orbital tilt, just like Kerbin, and its relative velocity to Kerbin is pretty close, so we don't have to worry too much about slowing down to get into Duna orbit. Now, this next bit took quite a bit of trial and error. In order to save delta V, if we're going to slow ourselves down at Duna by using aerobraking, which is an extremely common maneuver used in Kerbal Space Program, by using aerodynamic drag, we can slow down the craft enough so that we find ourselves in an eccentric equatorial orbit, and performing aerobraking can be kind of tricky because it's a balancing act between how fast you're going, how much drag your craft produces, how thick the atmosphere is, and how structurally sound your craft is. And misjudge any of those factors and you either burn up on reentry or fly past Duna and out of its sphere of influence. You can see I've got the ship pointed strictly radial out so as to produce the most drag and slow us down the most. Also, remember that this is only the successful attempt that you see now, and there were definitely more attempts made off camera than you see here. As I said earlier, this was only meant to get us into an eccentric orbit, and that it did, so as we reach our Duna apoapsis, I burn slightly prograde to bring our periapsis out of the atmosphere before burning retrograde at our new periapsis to circularize our orbit. Now that we've got the core module into a 130 kilometer Duna orbit, we're back to the VAB to work on the power module. And the body of the module will be composed of alternating reaction wheels and structural fuselages with several batteries and a docking port at the top. Because we're using those structural fuselages instead of fuel tanks, most of the mass of the payload comes from the solar panels and batteries, which aren't very heavy to begin with, making the entire payload extremely light for its size. On the sides, we'll place our solar array, and the reason for this crazy amount of solar panels is to compensate for our distance from the sun, because since Duna is further from the sun than Kerbin, solar panels produce much less power than they would normally. Something that you'll notice I do a lot is that I use the wrong size decoupler on the bottoms of my payloads, and that's because the decoupler I use is much taller than the standard ones, and that extra 3 feet between the bottom of the payload and the base of the fairing allows me to make much more aerodynamic and aesthetically pleasing fairings. Now, given the aforementioned flight payload, our transfer stage can be much smaller than the ones we use to launch the core module. I also set that the transfer stage and the ascent stage between all of my rockets stay basically the same, and you can see that here where I once again use the Rhino and Mammoth engine with Clydesdale boosters. Since the ascent stages are so similar, just to save time I'm going to skip the construction of the lower stages and go straight to the launch. Once again, we're using the standard ascent profile of heading 45 degrees at 10 kilometers, and after getting circularized around Kerbin, I again realized that I forgot to wait for the Duna transfer window, so the ship spends about a year orbiting Kerbin before we can finally begin our escape burn. I've been using MechJeb to automatically create the maneuver nodes to Duna since I have to do it so much, but MechJeb's a super useful tool that I've been using on almost all of my videos now, and it can do a lot of stuff. Like, for example, in my live Mun video, I used MechJeb to automatically do my ascent off the Mun, but I usually just use the maneuver node planner on it to speed things up since I already spend several hours at a time recording, so I'll just do anything I can to cut down time. And you might not be able to see it here since the video is moving so fast, but we keep getting these unintentional gravity breaks from the Mun while we're leaving the Kerbin system, and that really is just a hindrance since it cost me Delta V in this case, but there are actually ways you can actually use the Mun or Min-Miss to save you Delta V by performing gravity assists to get you into deep space. But anyways, here we are at Duna again, and I try to use aero braking again here, but we run into the issue where the solar panels on our craft don't have the heat tolerance that the fuel tanks did in the core module, and they burn up on our entry. So what I end up doing is, instead of pointing radial out, I point retrograde and do what's called an assisted aero brake, where I slow ourselves down a bit by burning some fuel, and that both helps to capture us around Duna and prevents overheating on the solar panels. This time we try to aero brake more than once to get us into a less eccentric orbit, which does save some delta V, but we inevitably do have to burn prograde at our apoapsis and circularize normally using our engines. Now, again, for the sake of time, I'm just going to skip over some of the circularizing and orbiting Duna, waiting for a convenient time to rendezvous with the core module so we can get straight to some of the more interesting bits. So now we're circularized around Duna and can begin rendezvousing with the core module. Now, generally the first thing you need to do when trying to dock two parts is to get your craft on the same orbital inclination as the craft you're trying to dock to, but we're coincidentally on almost the exact same orbital tilt, so we can basically skip that step. Second, since we're in a lower orbit than the core module, we're moving much faster than it, so we need to start our prograde burn while we're behind the core module. After having completed our prograde burn, we then warp to our closest encounter with the core module and burn retrograde relative to the target's velocity, so that we're now moving at the exact same speed as the target. Now that we're within several kilometers of the target, we can point directly at it and burn for a bit before facing retrograde again, and I do this over and over until I'm within visual range of the core module. If you're wondering why we can't just point directly at the target and burn for a bit and just coast until we're right on top of it, you have to remember that we're in a circular orbit, and while the actual speed of the core module doesn't change that much as it revolves around Duna, its direction's constantly changing as it orbits the planet, so if we burn directly at it at one point in time, once we reach that destination, the module will have moved. So now that we're within a few hundred meters of the target, we can ditch the transfer stage and maneuver the craft just using RCS. Now, I don't really do a ton of docking in Kerbal Space Program, so I'm not really that familiar with the RCS controls, but the way I understand it, you have two control modes, rotation mode and docking mode. Rotation mode is pretty self-explanatory, and it allows you to move only the nose of the craft, and is used almost exclusively in flight not involving docking. While docking mode allows you to move the entire craft horizontally, vertically, forwards, and backwards, and is, of course, used primarily in docking procedures. With the two modules now docked, we return to the VAB to begin constructing the Kerbal module. And this module is the lightest of the four to go on the space station, and as such, it'll get an appropriately small transfer stage. You can see that I've got the center of mass display up, and the purpose of that is basically just to tell me where to put my RCS thrusters so that when I fire them, they don't rotate the ship when I'm trying to dock. But other than that, I just added some communication equipment and Kerbals to stay on the station, and we'll go ahead and skip the construction of the lower stages and get onto the launch. So there's launch 3 out of the way. This module ended up being a bit tougher to fly than the others because the center of mass wasn't actually in the center of the craft, meaning that it had a tendency to flip out of control, particularly during the ascent. Generally, you do want your ships to have a center of mass, but it's possible to do with it off-center, like on the engines of the space shuttle, where they just rotate the engine slightly to compensate for the uneven weight distribution. Anyways, we're now in orbit around Kerbin and can go ahead, with the assistance of MechJeb, plan a burn to Duna. But first we have to wait for the Duna transfer window, so we'll do that now. As always, the maneuver node planner is never 100% accurate, so once we perform the burn, our trajectory is still quite a ways off. So once we're on our way out of the Kerbin system, we manually adjust our trajectory by pointing normal, then radial in to get a close Duna periapsis. This isn't the most efficient method of adjusting our periapsis, and alternatively we could use the maneuver nodes to avoid the trial and error aspect of it, but we've got more than enough fuel to dock with the Duna space station, and the maneuver node planner can only display burns as precise as 1/10 of a meter per second, which isn't precise enough to properly adjust course as needed. This time around, just to save time, I didn't bother aerobraking because we had such a surplus of fuel in the transfer stage, and it allows us to get a much faster encounter with the space station. This time around, we did have to burn normal at our target's descending node to line up our orbits, and orbital inclination changes can be really expensive. Like, to go to Dres, the orbital inclination is around 20 degrees, and to change your ship's inclination that much, it can cost as much as 1700 meters per second of delta V. For us, though, our target isn't that far, and the inclination difference is only about 5 degrees, so we're spared the effort. Again, we spend a while orbiting Duna and spinning around the planet waiting for an opportune time to burn to rendezvous with the rest of the station, so I'll go ahead and skip over to us within a few hundred meters of the space station. So what you're going to see here in a minute is the spaceplane takeoff. I skipped the construction of it because the entire ship only uses about 30 parts compared to, for example, the power module's 100, so there really wasn't much to show and I just wanted to save time. So here's the space plane. It's being powered by two Rapier engines with several liquid fuel and oxidizer fuel tanks, and looks pretty similar to some of the other space planes I've made. As with all ascents using the Rapier engines, we're going to fly as low as we can in the atmosphere to get the most oxygen possible running through the intakes until we reach about 400 meters per second, at which point the engines become much more powerful and we start climbing through the atmosphere. I had to pack a very specific amount of fuel on board for this flight because I wanted us to run out of fuel right as we got into Kerbin orbit and then have a second launch send up a transfer stage which would attach to the space plane and fly it to the space station where it could refuel and travel from Duna to orbit. The reason for leaving the space plane nearly empty was just so that the transfer stage wouldn't have to move as much mass, but unfortunately that's a lot easier said than done. I'd say that of the 4 hours of recording I did for this video, 2.5 hours of that was spent trying to make this space plane work, and in the end it didn't, as you'll see in a bit. Now that we're basically in orbit, for final time, we're just going to go to the transfer stage launch, and I'll skip over the construction of the transfer stage launch for the sake of time. It's basically just the rocket I used for the other 3 launches, but the transfer stage is instead the payload. The launch and rendezvous procedure aren't really anything special, mostly just us warping in circles around Kerbin waiting to get close to the space plane. Something I forgot was to add some reaction wheels to the transfer stage, which means that the entire ship could only be controlled either using the gimbal on the engines or the built-in reaction wheels on the probe core, which are extremely weak. This results in the transfer stage taking about 10 minutes, I'm not exaggerating, 10 minutes to rotate 360 degrees. At this point, because I basically can't rotate the transfer stage, most of the work has to be done by the spaceplane with its remaining 70 meters per second of delta V, and I had to do several attempts of this because 70 meters per second is not a lot to work with, so any tiny mistake means I run out of fuel. So my plan for this was to add a docking port onto the nose of the spaceplane once we'd rendezvoused so that we could ensure that when we docked, our center of thrust would be aligned with our center of mass. However, when it came to actually trying to weld on the docking port, for whatever reason, it wouldn't let me weld the docking port on the nose, which was the whole point of bringing the materials in the first place. Eventually, I just gave up on that and decided to use the already built docking port, which wouldn't allow me to align my center of mass and center of thrust, but whatever. And so after having done all that work and gone through the work of launching and docking 4 crafts, I began to make my maneuver node to go to Duna, and the game crashed. At this point, I've been recording for 4 hours, and I knew I needed to get this video submitted at some point, so unfortunately I'm gonna have to leave the year on this depressing note. Thank you Warfield for letting me do this. It's been really fun, and I've definitely gotten better at the game since the first mission I submitted. I look forward to taking your classes next year, of course, and yeah, that's about it. See ya.